Students, today we are going to see the towers of hanoi problem and its solution in C program. So here the task is to move n pegs from tower A to tower C using tower B as a temporary tower, and the condition required is that the smaller peg cannot be having the peg with a higher number above. That is the required condition. So the algorithm to solve this problem will be transferring n-1 pegs from tower A to tower B using tower C as a temporary or auxiliary tower. That is the first step. So this will be done in a recursive fashion. And the second step is that the last, which is the nth peg, you can now transfer this onto the destination tower, which is tower C. And the step 3 is now you have n-1 pegs in tower B. So these n-1 pegs now you can recursively transfer to tower C using A as a temporary or auxiliary tower. Let us see the programming part of this solution. So I am including the stdio.h because I will be making use of input-output statements, which are printf and scanf statement. And I am writing one function here, tower, which takes 4 arguments. First argument specifies the number of pegs I want to transfer, and the remaining 3 will specify the tower, source tower, destination tower, and auxiliary tower. And these names will be specified as characters. And it does not return anything. And I am declaring one global variable and initialized it to 1. So that is by using int c equals to 1. So this c is used for counting the number of moves made by the program. And inside the main I have declared integer n for reading the number of disk, and I am reading the value of number of disk into n by using scanf %d ampersand n. So this n will be the first argument which will be passed to tower, and the source tower I am labeled with the A, and destination is labeled with the C, and the temporary or auxiliary tower here is mentioned as B. And printf, the number of moves will be equal to the C, which will be holding the count of moves, is printed at the end. This is regarding your main function. And coming to the tower function here, the first argument integer will be stored in P, and the first character is from, and the second character is to, and the third character is temp. So my task is to move P number of pegs from to using temp as a auxiliary or temporary peg. So now the programming here inside the tower here is, if you have a single tower, so that is checked by checking if P is equal to 1. It means I have a single peg that I can directly transfer from to 2. So that is done by using printf move %d from peg %c to %c peg, and this %d will take the value of P, and the first %c will take the character from the variable from, and the second %c will take the character which is present in 2. This is the case when you have a single peg. Otherwise, if P is greater than 1, then I am recursively calling tower P-1 from, I want to transfer to temp using 2 as the auxiliary peg. So this is recursively done. And once this recursive function is called, I will be incrementing the counter C, and then I am printing move %d from peg %c to %c peg /n for going to the next line. And the first %d takes the P value, and the second one takes the from, because I have already n-1 pegs in the from, and second %c takes 2, and I am calling recursively tower p minus 1 temp to from, and after calling this tower again I am incrementing the counter. So this is regarding your recursive towers of hanoi function. So let us see the output. So this is a pictorial representation of this. So now here the first one represents, I want to transfer 1 from A to C. So we'll run here with the value of n equals to 3 and check the answer. So the first one, move 1 from peg A to C. That is what here it is done. The second is move the second from A to B. Move 2 from peg A to B peg. Third move is move peg from C, peg 1 from C to B. And fourth move is move the third peg from A to C. The next will be moving the 1 from B to A, and the next will be 2 to C from B, and the last will be moving this that is the first peg from A to C. So the same output you can see in the program output also. This is the same output what it is shown in the figure. So the number of moves will be equal to 7. Thank you.